Do you guys hear me? Okay. So we have developed a dynamic tool destination that works with any tool and any destination. So as a bit of background here, we deployed Galaxy, well, I deployed Galaxy back in 2010, and we had a big rebuild in 2012, so that's kind of where the data is from. So at last year's GCC, we had only ran 250,000 jobs since beginning, and 150,000 jobs were run since the previous GCC. And we had ran some forecasting using R and the forecast module, and it said that we're going to run 250,000 jobs between GCC 15 and 16. Well, that was wrong. We ran 750,000 jobs, 104,000 jobs this month so far. So we're at 1 million instead of 500,000. And if we look at this graph here, at the next GCC, we should be at 3 million, but we were wrong last time at 500,000, so maybe 6 million. Let's see. So here's kind of a toy example of why you would want to use a dynamic destination. If we imagine we're running a tool here with 3 different parameter sets, you can see by the shaded area in the box that the resources that are actually required, and the area is basically what we've requested. So we request more than we require, which means we are wasting resources. As seen here, if the top is kind of the width of our cluster, you can see that we have 0% free, so we can't run any more jobs, but our cluster is 41.7% idle. And the bottom here, the idle amount is the same as the free amount. So that's what we want. So why use DTD? So yes, DTD is a dynamic destination, and you could write your own. Typically, from the examples I've seen, those are per tool. Ours works for every tool, every destination. We're not modifying the RMA native specification. We are actually returning the ID of the destination. It's easy to use. It's a YAML configuration file, which I'll show in a bit. There's limited restarts, so once you have all your destinations set up in JobConf, you can update your YAML configuration on the fly with no restarts. You have 6 different types of rules. So file size, so the size of the input data sets, number of input data sets, arguments, so what arguments are present, which could be useful for assembly, and you have error correction on. Records, so we use the Galaxy metadata for FASTA files, for example. And a user, so if a user runs this tool, you could make it fail if you wanted to, if you don't want them to run it. And it's on GitHub. And yeah, open source Apache 2 license. So this is what it looks like. If you see my poster, you can kind of see, this is just kind of saying how the logic works. Basically, DTD is our default destination. So when you go there and you don't have a config for your tool, there's another default in there. If you don't match any rules, just send the tool's default destination. If multiple rules are matched, we use nice values to choose which one we should go to. If the nice values are the same, we go to the first rule encountered. So here is what your job conf could look like. Ours is not this small. We have about 500 destinations set up in ours. But the important thing is at the top. So we defined our default destination as DTD using our function. And then here I have 3 different examples. So default, 1 gig, 1 core, 4 gig, 4 gigs. And here is the biggest part of it. So this is our tool destinations config file. So here we have tools at the top, small map, rules, so the file size. So when you're between 0 and 2 gigs, you go with the Slurm 4-core 4 gig destination. If you're 2 gigs and 4 gigs, you go to the one with 8 cores and 8 gigs, etc. So this is what it looks like. So that's kind of it. I was just going to mention here the Galactic Radio Telescope by Eric Rashi. The Galactic Radio Telescope will collect stats on jobs run between galaxies that can opt into reporting their data. And once we build up a huge collection of data, we can generate automatic rules for you to optimize the resources used. Yeah, and then so in the future, we may add more rule types. You know, maybe the community can help me with that. But that's it. Any questions?
Thank you, Eric. Any questions for Eric? I wonder, sometimes the resource usage is dependent on the input file, and I wonder if you run into that situation and how you control kind of the dynamic destinations that way.
Yeah. Was that a comment or was there a question there?
I guess that's a question about how you handle that.
How we can handle that or how we decide?
Yeah, what you do when you run into that situation. So do you run out of resources that you've made an initial guess at because
Yeah, so it's kind of, we're just updating it as the fly. As we see jobs fail, we increase the amount of resources for that area. So it's kind of an ad hoc basis, but
yeah.
Sort of related to that, I mean, our cluster's probably got 100% use in slots, but 50% use in resources, and I think that's the problem you're solving. I'm glad you're working on this. This is great. And I'm wondering if you could expand a little bit about how you're going to do automatic configuration, sort of learning from like the community, or do you want to learn from the local like job execution history and resource allocation history?
So with the Galactic Radio Telescope, it will basically collect resources. So you could set up your own local instance of that, so it would just learn for your center, or you could submit to the public one once it is made available, and then we could pull off of there. So it depends what you want to do.
Thank you.
Okay.
I think